Hi everyone, in this video I'm going to talk about the concept of intersection in probability. Topic is intersection. Okay. Let's say we have two events A and B. So A, B are two events. Okay, and then A intersection B, the way we do know it's A, it's like a bridge, intersects B. So we call this A intersects B. Okay. So the definition for A intersects B, it's the set, right? It's the set containing all outcomes that A and B shares. What it means, so if A intersects B, it's a set of outcomes that each outcome in the set has to be in both event A and event B, right? So it's not union, union is or, right? It's or A or in B. But in intersections concept, then this outcome has to be in both event A and event B. Okay. Let me give you a Venn diagram description of this. So the Venn diagram. Okay, so remember we have a rectangle and then the whole space is our sample space. Intersection, so we have event A here and event B here. Okay, so this shaded area, they're shared by A and B, right? So it's in A and it's also in B. So this shared area is what we call the intersection. Intersection, right? So for an event to be in this set, it has to be in A and in B. Okay, cool. Let me give you an example to show you how you can find intersection of two events. Okay, so in this example, we're going to roll a die. And let's say event A is we get an odd number. And then event B is that we get a 5 or a 6, right? When we say odd numbers, we mean 1, 3, 5. Okay. So what's A intersect B here? A intersects B. In this case, we're looking at an outcome that's in both A and in B. So in this case, 5 it's in A and 5 it's in B. So which means that A intersects B is the set of just 5, just one value here. Okay, so this is if we show it in the Venn diagram, it's in the shade area here. Now, if we add one more event, C, right? C is the event that we get an even number. So that's 2, 4, 6. And what's the intersection of A and C, right? So what's A intersects C? As we can see, A is all the odd numbers and C is all the even numbers. So which means that there's just no intersection in between, right? So 1, 3, 5, not here. 2, 4, 6, not here, right? So this equals to the empty set, right? So there's no intersection between the two events. Okay, good. Next, I want to give you one formula, but two versions to show you how you'll be able to calculate your intersection in probability. Okay. The formula the probability of A intersects B equals to the probability of B given A multiplied by the probability of A, right? So what it means? It means is that we need to find the intersection of A and B. So we want to see, given A happens, what is the probability of B will happen, and then multiply by the probability of A happens, because we conditional on probability A happened. Okay, right? So this can also be written as probability of A given B multiplied by probability of B. Okay, so that's the formula we can use to calculate the probability of A intersects B. Let me give you an example of how you will apply this formula. Okay, so example. Let's say we have 160 economic students, 70 business students, and 30 undecided students. Undecided students, say in a big class. This sum up to a total of 260 students. So I want to randomly, from these 260 students, I want to pick 2 students randomly. So randomly pick 2 students. And I want to ask the question, what is the probability that both of these 2 students I picked are business majors? Okay. So the question is, what is the probability that both students are business majors? Okay, so how can we rewrite this question in terms of events? So both students are business, which means that the first student you pick has to be business, and the second one you pick has to be a business major, right? So I can write this into the event A. The first student is business. B is the event that the second student is business. Okay? Then I want to find the intersection of these 2 events, right? The intersection of these 2 events would be the result that these 2 students are both business. Okay? So this question, you can go to probability of A intersects B. Okay, right. So we can apply this formula here. So the first one and the second one will work. Probability of B given A multiplied by the probability of A. Okay, so when solving this question, some people would like to write this one first and then this one second, because the probability for this one is easier to calculate, and the probability of this conditional probability here is based on the result of this one. Let me show you. So if I rewrite these 2, probability of A times the probability of B given A here. Okay, let me switch to Oh, well, let me just continue from here. Okay. What's the probability of A? Probability of A means that the first student is business major. So we have 260 students and 70 of them are business. So of the total 260 possible outcomes, 70 of them are business. So this one is 70 divided by 260. Okay. And now we have to think a little bit for this one. So what is the probability to be conditional on A? In this case, A, it's the first student is business. And then we're conditional on A. That means A already happened. So if A already happened, that means you already pick out one student out from the 260 total. So now you only have 259 students for you to pick out for the second student. And then 69 of them are business, right? So after the first one is business, this one turns to 69 and this one turns to 259, okay? So the probability of B given A is 69 divided by 259. And when you multiply by the 2, and that is the probability that if you randomly pick 2 students, the probability that both of them are business. So as you can see, this formula here is pretty useful. Okay, good. Next, I want to give you one more formula here, trying to expand this one. Let's say if you have 3 events, and then you want to find the intersection of the 3 events. Okay, this is again a formula, so I'll keep the formula here. So the probability of A given intersects B intersects C. Okay, so these letters are arbitrary. You just have to follow the pattern and you can get your formula. So what I'm going to do, let's say I'm going to pick out the first event A, so equals to probability of A multiplied by probability of the second event conditional on the first event you write here. Okay, and you're going to multiply by the third event C and then conditional on the previous 2 events. So intersects. Okay, so yep, that's it. And that's the formula if you have to calculate for 3 events, the intersection of 3 events. Okay, cool. Next. Okay, more formula. As formulas, right? More formulas. And then the next formula I'm going to talk about is based on the 3 main formulas that we discussed in the previous videos. So let's say back to 3 main rules or formulas, right, of probability. Remember that we discussed, right, the third one that we had, we talked about if A and B are disjoint. If the 2 events are disjoint, then the probability of A union B is equals to the probability of A plus the probability of B. Okay? But usually we don't get them to be disjoint. What if they're not disjoint? If A and B are not disjoint, right? So if A and B are not disjoint, what's going to happen here, right? So if we look at the Venn diagram, A, B, and this their intersection. If A and B are not disjoint, and then if we calculate the probability of A union B, then using this formula here, probability of A plus probability of B, then you get the area here, right, for A, and you get the area for B. When you add them up, you double counted this portion here, right? So this intersection is being double counted. Intersection double counted, right? And this won't be right, because you counted this part twice. Okay, so if A and B are not disjoint, you have to change this formula a little bit. Okay, so we're saying that A and B are not disjoint, right? So if they're not disjoint, then the formula you have here, probability of A union B equals to probability of A plus probability of B. But instead of stopping here, you're going to subtract out one piece of the intersection here. Since it's been double counted, you're going to minus probability of A intersects B. And that's the formula for when A and B are not disjoint, right? But as you can see, this formula can also give you another thing. It's the connection between union and intersection, right? So if you're given probability of B, A and B and the intersection probability, then you can calculate the union. The opposite is true. So this is important formula. And then probability of A intersects B equals to probability of A minus plus probability of B minus probability of A union B, right? So what I did, I just switched them around. But as you can see, now you'll be able to calculate the intersection probability by having probability of A, probability of B, and the probability of the two union. So these two are very important formula here. Okay, let me again do an example to show you how you would apply these two formula here. Okay, so example, again, you're going to roll die. Event A is you get odd number. So you get odd number, and this equals to 1, 3, 5. Event B is you get 1, 2, or 3, right? You get 1, get a 1, get a 2, or get a 3 here. So what's the probability of A intersects B? Right, the probability of A intersects B, you can use probability of B given A multiplied by probability of A. Okay, good. So what's the probability of A here? The probability of A is you get an odd number. So the probability of you getting an odd number is the total 6 possible outcomes, and then 3 of them satisfy your event A here. Okay. So knowing you get the results you get is an odd number, what is the probability that you get event B here? Okay. So inside this event B, 1, 3 are in this set here, right? Are in this event, right? So conditional on knowing you're getting odd number for sure, then you already cut down your sample space to 3. And then 2 of them satisfy the event B, so the probability that you get B conditional on A or given A is 2 over 3. Okay. So the result here is 1/3. Okay. So we got the intersection probability. Now I will apply this formula here. So I will ask the question, what is the probability of A union B? Okay, probability of A union B, apply the formula, probability of A plus probability of B minus probability of A intersects B. Okay, very good. So what's the probability of A? So this is easy, right? Probability of A is of the total 6 possible outcomes, 3 of them are odds. What's the probability of B by itself? The probability of B by itself is the total 6 possible outcomes, and then 1, 2, 3 are gonna satisfy the event B. So plus again, 3, 6, and then you get minus A intersects B, that's 1/3 here. And then you get 1 minus 1/3 is 2/3, right? Okay. So probability of A union B in this case equals to 2/3. Okay. And that's how you will apply these two formulas here. Okay. Good. So in this video, we talked about the concept of intersection in probability. And thank you for watching. I'll see you in the next video.